I'm sorry. Is that it?
That is,
That's
you can
fucking
see
right.
you can see a pixel hanging out there, but
Let's not talk about that pixel. Someone's gonna notice that my Reddit handle is Smash Capitalism, and I've never posted anything, but like that's fine.
yeah, I think that's fine. We're pretty unembarrassed about our political preferences on this stream.
Yeah, it's I was
I got a couple upvotes on my Reddit link last time.
nice.
That
So
means that at least a couple of people saw it.
yeah, I think we had some guests from it. I'm trying a technique today where I'm using a link post instead of a text post
Oh, because you get the unfurl and
because
everything.
you get the unfurl and the embed.
Yeah,
So we'll see. Uh,
yeah. I used a slightly sassy text description last time
I
to see if
enjoyed
that
it.
would. But
I think the
I think
SAS
the
probably
image is.
worked.
Yeah, I think maybe let's do a crazy image where we're both like YouTube preview images where we're both like wide-eyed with like a weird face on a weird expression in our mouths. Like,
I wonder how we can do that. We might need to set up a Twitch title card for each stream, but that would be very worth
oh,
it.
is it stream by stream that does it?
I
Or we can just do it like in our open graph metadata on jeffandom.com.
because we got that now. It's super
Well,
good.
it could be like we could make a path that's like the Twitch forwarding path that all it does is redirect to our Twitch channel, but it has open graph and lets us do stuff like this.
I like it. Wow, the stream actually looks really great. Your video's coming through a lot clearer. So,
And look, the game,
oh, I was on Talking Heads, but let's look at the game.
it's running.
Ah, it looks beautiful.
It's got all the new stuff. It's got all the stuff as of an hour ago.
Oh wow, it looks great on Twitch. So
Gosh,
we're doing it.
this game is amazing. It's the best game ever.
It's weird how that's true every week, and it doesn't change actually.
It gets more and more true every week.
Yeah, it remains exactly as true. I'm with you.
So I want to hear other things that are true. I want to hear your takes about football and the occurrences of this weekend.
Oh man, I mean my team sure got clobbered.
Okay.
The New Orleans Saints are no longer.
They just like decided to cancel the team. Is that what happened?
Yeah, it's fine. It's fine.
It's they abolished the team. It's just like
Yeah, and
okay.
it was time. It was time. No, it was a very interesting football weekend.
They resigned from the proverbial Trump administration of their season.
Man, I can't believe that we got to deal with Tom Brady now. Of all the people who should have gotten resigned from the administration, it's that guy.
Yeah, yeah. Is he going to retire? He's pretty old, right?
He's older than our guy who is retiring, but I think he's got another. I think he's got another year in the tank.
Okay.
He's like a freaking robot, man. It is so unclear how he's still going.
Drugs? I'm assuming they're all.
I
on
assume
some
all
kind
football
of,
players are on drugs. Yeah, probably like really good, expensive ones that don't show up on drug tests.
Yeah.
But yeah, football good. I mean, I don't know. It was heartbreaking. I was actually happy to be distracted by the MIT puzzle hunt this weekend because I kind of like didn't have to feel all the feelings right at once. Man,
Oh, the mystery hunts.
the mystery hunt. Excuse me.
Did you have to learn Klingon? This is excellent.
No, I went to the site. I saw it, and I was like, oh man, a Klingon dictionary puzzle right up my
Qapla!
alley. And then someone was like, oh, that's been the banner image for like 5 years. And I'm like, fuck, missed out.
I love this web design, like kind of classic skeuomorphic web design.
Yeah, I was gonna say, all things considered, they made an entire MMO this year,
Yeah.
which was truly, truly impressive. And they did it. There was like a lot of video game sort of stuff. Like they had like 600 people online in a Unity MMO at once, but also that's last year. That's 2020. We're in
Oh.
2021 now, baby. I don't know if it's up yet. It might. If you go to
Foiled my robust hacking attempt.
yeah, if you go to perpendicular.institute, that's the current site, but you might need a password to get in. .institute, yeah.
Have you looked at all the various domain names there are out there? It's awesome.
It's an utter delight. Yeah.
There's dot .pizza.
I own
What else is there?
I own Dominic.cool.
Dominic.cool. That's a good one.
Yeah,
Dominic.wtf would be a good one too.
Yeah, I think I have Dominic.cool and Degrati.family are my two like
Oh, that's
vanity
awesome.
domain names. Yeah, they're good. They're good names.
I have jeffly.site. A little bit boring, but it's the only Jeffly I could find. I can also get jeffly.jp,
Can you
which
get
would be kind of cool.
Can you get Jeff.zone? Enter the Jeff zone.
I doubt it.
What the fuck? Great.
No, this is a self-deprecating
Yeah,
title
yeah.
to a yeah.
That's great.
And we have to give this person credit, regardless of who they are, that they had the wherewithal and foresight to register the Jeff.zone domain name. Yeah.
That zone is where it's at these days. They know what's up.
Yeah, what the hell is this?
What social network was that? Last FM.
Is this Instagram?
It's Instagram. That's a classic Instagram. Boy,
Do you remember Hipstamatic?
I do. It was so nice.
Yeah. Last FM. Crazy. So you were playing the MIT Mystery Hunt.
Yeah.
What was the best puzzle?
I think the best puzzle was they rebuilt. Have you played Keep Talking and Nobody Explodes?
Yes.
So they built an entire version of that needed 6 players at once, where instead of the bomb in VR, you're all looking at one side of a cube bomb,
Okay.
and you have to rotate it to like solve the puzzles and see all the sides. But when it rotates for you, it rotates for everyone.
Oh, that's challenging.
Yeah, it was extremely hard. It took us like 4 hours of practice to be able to like beat the game, and they didn't make it easy.
So does it actually blow up and then you're dead for good, or you just have to retry from the
You
beginning?
just have to try again. Once you finish it, you get the answer to the puzzle, which was like the word Panasonic or something.
Oh,
Yeah.
okay.
Yeah, everything is like sending you towards like 1 or 2 word answers that are like relatively short, and then those answers end up being puzzles in their own later down the line.
That sounds really fun.
It was a really really good time. This is the first time I've ever done this particular one, and I will definitely do it again.
And so who was on your team?
We had a really tiny team. It was just like some friends that we know from Boston. I don't know how we got connected to them originally,
Right.
but like yeah, extremely small, and just I don't know. We were like 20 or 30 people, but like the team that won was 200 people. So like yeah, people don't fuck around.
How do you have 200 people playing the same thing? Is it just divide and conquer on different puzzles?
Yeah, I think so.
Okay.
Honestly, it sounds unfun.
Yeah.
Like I don't really want that.
Yeah.
And I'm glad that like I was playing with people who didn't really want that either, because like I don't know, the whole point was to have fun and not to be really bent out of shape about winning or losing.
Right.
But the winner has to write the next puzzle hunt. So
Oh, that's crazy.
yeah,
So there's 200 of them to do it, right?
right. Yeah, so it's like it's kind of scales up to like a certain size. Like there were hundreds of puzzles. You need a lot of people to do it. Clearly, you need a couple web engineers.
Yeah.
It was a good time. And then I took today off, and I took tomorrow off. Well, today's a normal day off. I took tomorrow off.
Oh, what are you going to do tomorrow?
Nothing.
That's awesome.
Yeah, work on this game, play some other games.
Yeah. What are you playing lately?
I started Maneater. I'm a shark.
Oh, that's right. You told me about that.
Yeah, it's fun.
Have you got, you can like mutate, right? You can become like a bigger shark over time.
Yeah, I've grown up once. So I'm a teen shark now, which they didn't write a song about, weirdly.
Yeah.
Yeah, I like it. It's good. It's like kind of an open worldy. It's like a weirdly generic open world RPG that just happens to be about sharks. It's great.
Oh, cool. And you can become this guy right here?
You can become that guy, yeah. Or that's
bloody brilliant. That's the review.
strong review. I agree with that.
Oh, dude, what?
Yeah, I mean, you eat a lot of people. It's great. You're like...
And the people like realistically deform like this? Is that...
Oh, yeah.
Because like this person is...
Yeah, they lost
missing a
they
leg.
lost a leg, for sure,
Yeah,
sure.
that's it's not a healthy person right there. They're not a... No.
No, and the whole thing is like this weird reality show pastiche where like they're filming it from the perspective of like shark hunters on the bayou who are trying to like catch a shark. It's bizarre and like for some reason set on the Gulf Coast and has a real southern vibe for me.
And so you can become this like bitchin' armored shark.
I guess all I've got are electric teeth so far, which is cool.
This is like a shark by way of League of Legends, right? This is kind of what that looks like.
Ooh, yeah, exactly.
Yeah.
Yeah.
Too cool.
It's cool. The I'd say the biggest downside is that it's like a space game, right? You have like 3 dimensions of control
Yeah.
until you hit the surface of the water, at which point like you kind of lock into the top plane and it's very confusing.
Yeah, so it's kind of hard to control then.
That's like my only critique so far, is that the control is just super wonky. But like,
Well,
you're a shark.
On your recommendation, I did get the free PS5 version of Maneater.
Oh yeah.
Through PS Plus.
Yeah. Well,
And so in the year 2030, when I get a PS5, I too will be playing Maneater.
yeah, there you go. How much is a PS5 on eBay now? It must only be like $650 or something.
Yeah, you'd think that the price would just go down over time. Right?
I think it's been dropping. Yeah.
PS5. Disc version deodorant bundle free. What's that? Oh, that's a joke, right? So actually,
That's a
contrary
really funny
to our,
joke.
it is pretty funny. Contrary to our guess, it's actually more expensive than it was before.
That is weird.
Yeah.
I'm shocked.
So is it just these people that are buying them? Is that what's happening? Is it just the eBayers?
I think like the eBayers have gone hog wild.
Yeah.
Which is really just like too bad.
And why do they put their names here on it? What is the?
Oh, I think it's like because it's a unique photograph, right? It's like not a photograph that someone else can forge or say is theirs. You've got like, you can say like, oh yeah, I got this PS5. It says this in the photo. That's bizarre.
This is like their eBay username.
Yeah. It must be because like eBay was cracking down on forgery or something. So way to dox Crucial to 2K4.
Yeah, nice. Well, dude, you're gonna get some hate tweets for being a scalper.
That's like $300 cheaper than it was in Christmas though. So, they'll be out soon. I think once you get a COVID vaccine, you'll be able to get a PS5.
There's if you listen to Triple Click podcast, they kind of had like a gallows humor type prediction. They were like making bets essentially, like, are we going to get COVID vaccines first or PS5s first?
I honestly thought I would have gotten COVID vaccine first.
Yeah, I think it's kind of a race, right? I don't know. Vaccine rollout's real slow.
It's so slow, dude.
But apparently the PS5 launch was like the biggest console launch of all time. Did you know that?
Yeah, it like wouldn't have been such a big deal if we weren't trapped in our houses.
It wouldn't have been such a big deal because you think that the supply chain would be more efficient, or that you'd have other stuff to do and not worry about.
I think you'd have like, it wouldn't like, you'd have Christmas with the family to go to.
Yeah.
You'd like be going back to work. You wouldn't have like uninterrupted months of like, hey, I got a free night.
Yeah. Yeah, I mean, certainly it's been basically everyone leaning on video games to sort of like, self-care basically throughout this entire thing.
Which has been spectacular self-care, but also like, yeah, dude, this is real annoying.
Yeah. So you were playing Maneater. I played more Red Dead Online.
Oh yeah, getting your Red. Is it fun? Still fun?
It's not fun, but you kind of want to play it. Like I don't know. I actually think that was like one of the reviews I read about Red Dead Redemption 2, which is what Red Dead Online is based off of. Mm-hmm. Or at least Red Dead Online was upgraded into like all the tech and world of Red Dead Redemption 2.
I really like it's not fun, but you still kind of have to play it as like the review.
Yeah. The review that I read of Red Dead Redemption 2 is that it was like stubbornly unfun. But it would like the review goes on to kind of like laud it as a kind of like as a work of art, like an achievement in the history of video games. But like they choose to simulate all of these random things, right? They simulate your horse getting hungry.
Mm-hmm. Yeah, I played a little bit of the single player, and it was like it was too much for me.
Oh, wait, so you have Red Dead Redemption 2.
I actually have a copy of Red Dead Redemption 2, yeah.
Now lying fallow, okay.
I would hop in on some Red Dead action one day, for sure.
Okay. Yeah, there you go.
Yeah.
It's Red Dead Online is $5. So
Oh, that's
it seemed
interesting.
like a
But
it seemed
if
like an
I
interesting thing to try.
if I have the game, do I need? I don't need anything else, right? I don't need to pay for online too.
You have to play through the tutorial, which is 2 hours long.
Yeah, okay.
Actually, I don't know if you have to. You might not have to.
It must work differently because, like, I know I'm sure I don't get like all the superpowers the main character has.
What superpowers is the main character?
Just like being a main character, like you have like all this inventory space and like a ton of fast travel. Like the whole game is built around you being one person, but I assume the dynamic changes for multiplayer a lot. Like
Yeah,
GTA Online did that too, right?
I I actually wouldn't know. But it's by far the buggiest game I've ever played in my life. Like there's this one time where I kept there was this horribly grotesque render accident of a cow like sticking halfway out of the ground. Like that game has a really hard time. Like we talked about how I would like fall through the ground in Red Dead Redemption 1, right?
Mm-hmm.
And it for whatever reason continues to be a problem. 12 years later or however much time has passed. And I guess when you're standing above a cow, that's when the kind of like you can skin an animal kind of like detector. Like I guess it just works by you being physically above the animal. So I kept trying to skin this cow, but it was clearly alive, and its head was like all wonky and weird, and it was like slinking along the bottom of along the road like some kind of shark coming out of the ground. It was, and I was just like, just another day in this fucking game, because it was like very typical of everything that I'd seen in this game.
That's really funny.
Yeah.
Oh, shout out to ESK1404 in the chat who says, I've never heard the concept of main character superpowers divorced from regular game abstractions, but it's great. Yeah. They always depower you for multiplayer. Master Chief the same way.
Oh. Yeah. I mean,
you get like half the inventory.
Yeah, I think I said this last time, but you basically start off in Red Dead Online looking like a hobo. And that's your whole incentive structure, is like, I don't want to look like a hobo anymore. So you begin to accumulate, you begin to like shoot prairie dogs and sell their hides for 50 cents. And then if you do that 1,000 times in a row, you'll have enough money to buy a hat.
Oh lordy, that sounds terrible. All right,
it's like industrial England or something like that.
I'll install it on the PS5 and see how it goes.
Yeah.
Is that upgraded? It's probably just faster.
What?
Like, do I get 60 FPS or something?
Oh, Red Dead Redemption 2.
Yeah. Not clear. Oh well. Let's look at GitHub.
Well, let's look at freaking GitHub. Yeah. Okay. So, context. Well, first of all, you have submitted a nice little PR here. Mm-hmm. And the whole goal of this is that we wanted to be able to look at the geometry that's coming out of Blender, for example, out of a file that gets kind of spat out by Blender. We want to be able to load that into memory, and then actually do something with that data structure in JavaScript before we feed it into OpenGL, or WebGL rather, which is not a capability that we had before, because prior to that, we were just feeding the contents of the data file essentially directly into the WebGL interface. No ability to kind of like look inside and do any kind of introspection or manipulation or anything like that. Right. So that's what this PR has given us.
I did a good bit of research before. I was like, is there any way I can read from a WebGL buffer? And everyone's just like, no, dude, it's gone. It's in the graphics card forever. Goodbye.
Yeah. I think you technically can, but it's not worth it. It's like slow.
There's like no, if there's a way, there's not like a clear API for it too.
Oh, I see what you're saying.
Yeah, it's like they just cut off the structure at the point of being able to read bytes back out of it. So even if you could, it's probably really hard and not worth it.
Right.
But I really like what we came up with. So
yeah. So the load GLTF function, which is in the renderer currently, now gets.
So yeah,
a model node.
So the model nodes sort of are
yes.
Yeah, our model node is sort of the ungraphics carded format. Like it's just JavaScript arrays of whatever type came out of GLTF. They're uint 8 or 16 arrays, depending on what was specified.
Yep.
And they're ready to be processed. And then I put in the concept of processors. And the only one that exists right now is just a pass-through processor, which just takes whatever's in the structure, writes it into a GL buffer, and calls it a day.
Yeah.
So actually, if we got a line or a point set from Blender, that would work with this as well, because it's reading the primitive type out of that and just like handing it off to the graphics card.
Mm-hmm.
So I didn't want to limit us to just being triangle only, even though I called it triangle render node.
Right. The fact that this passes GL in through here, because we're on the GLTF module right now, which, despite the name, we don't really want it to know anything about OpenGL itself. But we are passing the rendering context in here, and I think it's for a pretty unfortunate reason.
Just types, I think, right?
That started with me. Yeah, It was all me.
Yep.
Make buffer. I think this is where it goes, right?
Yep. Goes all the way down there, and it's really just to get that one value at the bottom, which is like GL dot. Yep.
Yeah. Component type.
That helped me. Yeah, it's just doing that.
This literally might be the same thing. Like, I bet that this value 5120, which is in the GLTF format, I bet this is literally just 5120. In fact,
yeah, look up GLEnum.
Is there a way for us to know?
Well, the type is called GLEnum, so whatever GL byte enum value is, probably.
What if we did this?
Yeah, that'll do it.
How do we get the rendering context? Do you remember?
I mean, you could make a new one. That's got it in GL.
What is it? GL byte?
GL underscore byte, yeah.
Oh, just byte.
Just byte. Ha!
Yep. Yep. So what if we, instead of calling this...
And we could cast a GLEnum really safely.
Yes, we could. Because it would be unfortunate if the GLTF type... Actually, I think I wrote this, right?
You
Access
did, yeah.
component type?
Yeah, totally.
Yeah, and I think I read this out of the spec. I read this out of the spec.
Oh, that's funny.
And I actually think it's just a GLEnum. Like, it's literally just so I actually think it probably is okay if we did something.
I'm thrilled to see this getting out of there. So that sounds great.
Yes.
Sorry. There was another thing this needed to do, which was write everything into GL buffers, which I've extracted.
Which you've gotten rid of.
Yeah. So the fact that there's only one reason that this still exists is not totally historical. Like, I think it wasn't here for very good reasons.
Okay, got it. So accessor.component type
as GLEnum, and that should do it.
Or what we could do. Where is this used? I do like this new right-click menu. It feels very mature.
That and the new pop-ups for Big Sur are like nice.
Yeah.
Everything else is just not, though.
What if this was just...
Wow.
Do we want to use GL values in this? Is that okay?
I mean, it's what it is. So, like...
It is what it is. Right?
And that's a JavaScript type, and I think having that be a GLEnum makes a lot of sense.
Yeah. And then what that did is...
Well, you have that entire switch statement that's just about to get wiped out.
Yeah. Well, we don't need this function anymore, right?
Nope.
Where was this getting called again? Sorry. Just leading us in circles.
Just the one place. Second place. Interesting. That's
component type should just be GLEnum here, right? And let's just make sure we're type safe, because this
lacks return statement.
Oh, I see.
It does. That's interesting.
Oh, because it was trying to go through each one of these things. Well, because I'm trying to go through... Okay, so I do see the utility of having that type there. Real quick. What we're going to do... can I get another terminal? Is that possible?
But that type was fine. We just don't need to do the pass-through anymore.
Yeah, I think I'm just going to do the thing that I was originally hoping to do, which is not the cleanest thing, but it'll get us around this particular ugliness, which is where did we actually use GLenum again?
Access a component to GL. Yep.
Oh, in the renderer. Okay. So it's literally just like return T as GLenum, right? And then where were we?
That's the one that's just called in this file. Like you could just... That could just be access component type as GLenum. Yeah. Yeah, and then
which means that this function call is gone.
That one's gone. Yeah, the other one is still useful.
Yeah. And great. That's it.
Yeah.
And then we can start to get rid of the fact that we're passing that through, right? We should actually have some linter errors at this point.
Shouldn't we?
Yeah. Well, I guess it's not calling it a linter error.
You know what it is? Oh yeah. I wonder if you haven't set up. Nope. As I say, the errors are right there, but never mind. I forgot to turn on.
It's just not complaining. I mean, it should be complaining about the fact that we have an unused argument, doesn't it?
So I've noticed that the problems tab and the editor seem to be doing two completely different things. Because I've had the problem where ESLint wasn't running my editor for the last couple weeks on the M1, and I just fixed it today. But it's just like I forgot to turn on format on save and ESLint as the linter for a file.
ESLint is running. All right, let me just push this through.
Yeah. No, yours is, you already set up all your stuff better than I did, so seems fine.
And presumably we don't need this one anymore.
I don't think we need it all for make node. We do need it for getting the renderable buffer, but that's it. Yep.
That's still highlighted, so we are passing it somewhere. Oh, we're passing it to itself.
Nice. And then the next line in this file is where we do use it on 614, and that's perfect. Might be hidden, but it's off to the right. Sweet. Hey, the game's still running. Wild.
The game is still running. That's a good sign, right? And so in this file, I think we got rid of all of our GL. Yeah, we got rid of everything. That's beautiful. That's really nice. Okay, we scratched that itch. I do have the feeling that potentially this function we might want to get out of the renderer and stick it into whatever's managing the loading.
It's funny because this is what's a super generic interface, right? We have that model loader thing.
Yeah.
So maybe making a 3D model loader. Because yeah, I would love to sort of get some cruft out of the renderer and have it be really all about just getting stuff on the screen.
Get it lean and mean. And I think one of the reasons why I mentioned that is that this is a nice structure for stuff that we're going to want to wireframe. But if we ever don't want to wireframe something, we'd want to have a way of maybe controlling that, right?
Absolutely.
And it makes more sense to have this like those kinds of decisions totally outside of the renderer. Right? I'm getting Discord. I'm going to allow Discord notifications.
Oh man,
but
get ready. The new notification, like it's incredibly hard to close it, which you'll totally enjoy.
yeah, I'm going to go ahead and turn off Discord for now.
I'm surprised you got any notifications with Zoom on the screen, so that's weird. Usually when you screen share, it's hiding.
It should turn it off.
Yeah.
It should do not disturb.
It should have. You can still option click on the little control center icon to turn on Do Not Disturb.
Option click, you said.
Option click on the menu bar, yeah.
So if I just click regularly, it just pops up.
Yep.
And then I can just hit Do Not Disturb. Mm-hmm. And then could I just do...
Yep.
Until tomorrow. Okay.
Yep.
So option click didn't do anything.
It didn't do anything.
Oh, you know what it is? Because I got rid of the Do Not Disturb little icon. Like it had its own little icon. I turned it off.
Oh, you know what it is? They moved it. If you option click on Monday, January 18th, it'll toggle Do Not Disturb on and off.
What?
Because that's your notification center now. It's just the time, you know?
Good. Okay. Well, we figured that out. I'm learning about Big Sur.
Big Sur is confusing.
Yes. Okay. At any rate, I think this is kind of fine where it is for the time being.
I think we can keep moving stuff around, but definitely I want to think about line meshes tonight.
Yeah. Okay. Really quick, where we were going is trying to get wireframe rendering for these things going. And then there were two options for what we could do, both involving some kind of processing of the mesh made of triangles that we've got, and then trying to figure out exactly what we'd like to do with that. One option is to just create a completely separate mesh, which is not triangles, but lines instead. And we basically kind of like go over the geometry of the tank or whatever we're trying to draw, and then figure out neighboring triangles that are coplanar. And for those triangles, the whole point of the wireframe is to only draw lines on the edges of surfaces, even if the surfaces are made of multiple triangles. So we want to make sure we're not getting kind of sort of intermediate diagonal lines, and just emitting a bunch of discrete lines is one way of doing that. The other way of doing that was through the shader itself.
Y'all came up with a pretty wild algorithm for that at the end of after the last stream.
Yeah, which we spent a couple of streams trying to figure out. Trying to figure out how to do that purely within the shader. So I thought it might be worth at least talking about the thing that Steve came up with after the stream last time.
Absolutely.
Just so we can sort of like weigh the options.
Yeah, next time we're gonna give Steve some prep time too, because I like the way his brain just goes off on a problem.
Yeah, he's like, oh, okay, I figured it out, which is incredible.
Are you drawing? Do you want to put Miro on the screen?
Yep, I'm just loading it up on the tablet as well. Okay. Now the trick is just trying to synchronize myself because I don't know where I am. Why don't I do this general area-ish?
Seems reasonable.
Okay, so the idea is... Oh, cool. Showed up.
Yeah, it looks great.
Is there a way I can do straight lines in this?
The line tool, the little line with an arrow on it.
Going from bad to worse. This one here. Okay, this is promising.
Yeah, looks nice. I guess you can't hold shift while you draw on an iPad, huh?
No. This is a little klutzy, but it'll do.
Oh, looks great.
Oh boy.
Whew.
So let's say we've got this quad, right? Let's pretend that the edges actually meet at that one corner that's gnarly, right? This one right here, and also down here, and also over here, and also over here. Look, this thing is not great at like,
No, it's perfect.
letting edges join.
As I say, it's connect your line segment challenge 2021.
Yeah. So we really don't want to see this edge right here. This edge, is that visible at all? Yellow?
Not yellow.
Okay.
Yeah, it's barely visible in OBS, so it's going to be... Ooh, yeah, it's rough on the stream.
Yeah. So this edge right here we want to get rid of. But if we were just drawing outlines of triangles, we would see this, right? So the question is, how do we tell the shader not to draw that edge? When the fragment shader doesn't know anything about neighboring triangles. Like there's no built-in information in the fragment shader that will tell us information. We had some idea of like, oh, maybe somehow we could look at the normals of neighboring pixels, and if there's like a major discontinuity, we know that we're near an edge.
Yep.
Unfortunately, we don't have that information available to us.
Bummer.
Yeah. So that just means that we have to add information to the mesh that we can feed to the fragment shader, and then the fragment shader can use that information to make a decision on whether or not to draw something. So we've already spent like 3-ish streams now talking about how to use a fragment shader to even draw just outlines of triangles. Yeah, we got to the point where either we could draw the triangles with the edges, including that diagonal one, or we could draw the triangles with the edge cut out, but then also the corners weren't being drawn either, because the corners are on the edge as well.
I was gonna say, the best part though is that we do really, really understand the fragment shader now.
Yeah, we have a better understanding now. Okay, so Steve's idea, which I wouldn't have come up with in probably 1,000 years, right? Was essentially to label the edges. And right now, we're really only concerned about the triangle on the left, let's say. And then whatever logic that we use to remove the edge on the triangle on the left is the same logic that we could use to remove the edge on the triangle on the right, right? So his idea was essentially to label the edges of a triangle arbitrarily. You can kind of give them whatever labels you want, right? So let's just call it A, B, and C. And he said, why don't we add... we basically have to make a decision on what edges A, B, and C are, but it doesn't really matter what order they're in or how we letter them. As long as we're consistent in the way that we deal with them, then we don't need to worry about that. So he basically said we can add what is essentially 2 attributes to each vertex. It ends up being, we can optimize it down to just 1 attribute. But basically, we add 1 3-dimensional attribute to every vertex. That's not the normal. It's not a color, and it's not a position. But it is an indicator of essentially which edges are which edges do those vertices participate in.
Edges.
And
it's not. Do we need this on top of the barycentric, or is this also act as a replacement for that?
This should act as a replacement for the barycentric coordinates.
That's really cool.
Yeah. All right. Zoom in just a little bit so it's a little bit clearer.
Nice. You want to just take over the full screen?
Good call.
Yeah. Yeah, give you some wiggle room.
Yeah.
Okay. So this is great. I mean, this is basically what we were kind of trying to do, but had maybe lacked the understanding of possibility that Steve brought to the table for us, because we were talking about edge removal by passing more and more attributes in. So this is correct. This is good and feels validating, and I'm thrilled.
So we have some new attribute, ATT. It's actually a couple of attributes, but they all follow the format of having an A value, a B value, and a C value. Okay. Once again, the ordering of the edges don't matter as long as you're just consistent about it. And so the first thing that we're going to do to add to every vertex is we're going to set each one of these components of this attribute to 1 if the vertex is a boundary of the edge that it describes, that component describes. So, for example, this vertex here is is a vertex on the edge A. It's also a vertex on the edge B. It is not a vertex on the edge C. Right? So this vertex here, what is it?
So that's going to be 1, 1, 0, 1, and 0, 1, 1. And so really, we can do this. We don't have to think about what, like as long as you were saying, as long as we're consistent in how we arrange these on our triangle, it doesn't matter.
Yeah,
that's great.
So basically, what like for this vertex right here, the second component needs to mean the same thing as the second component on the other 2 vertices. That's all that matters.
But that's awesome because we don't have to coordinate like across. The triangles don't have to talk to each other. They don't have to know about the attribute value on the other side of it. That's perfect.
Correct.
Cool.
Yeah. So right now, what this is going to be, let's think about this really quickly. On edge A, we're just talking about like literally if you're on a fragment that's on edge A, your interpolated value for this attribute will be always 1 for the A component. It'll be somewhere between 0 and 1 for the B component. And it'll be somewhere between 0 and 1 on the C component. So right now, this isn't giving us enough information to kind of like decide whether or not we can remove something. Right? But the other thing that we add on top of that is we add a second attribute that has a similar format. It has an A component, a B component, and a C component. But what that attribute tells us is whether or not we should draw the A edge, the B edge, or the C edge. Okay? So the second component, which I'll try to use a different color for.
Interesting. Okay.
We do want to draw edge A, so we'll put a 1 there. And we don't want to draw edge B, and we do want to draw edge C, right? And I guess this is going to be the same for everything, because we need to be consistent.
Right, yeah, it's like a universal, like that attribute is actually not vertex specific, but triangle specific, which is interesting.
Yeah. All right, so what happens if we multiply those values, component-wise?
Oh, interesting.
Yeah, so the component-wise multiplication is 1, 0, 1 up here, 1, 0, 0 up here, right? And then 0, 0, 1 here. All right, and so what happens if we interpolate the purple values?
If we interpolate the purple values...
Let's talk about edge A first.
That's really cool. Edge A is always 1.
Yeah.
The whole way through. Oh, man. Okay. That's really clever.
Edge A is always 1. Edge C, also always 1.
Also always 1. And edge B is never anything.
It's always 0.
Yeah.
Right?
But it never even an intermediate value. Oh, I love it. Okay.
Yeah. Now, importantly, this actually solves the corner problem. Like, we had a problem with our technique last time that just used very centric corner, or we added like we added a scalar value, a scalar attribute to every vertex, right? That was like basically said, the edge opposite me should not be drawn. The problem with that is that the vertices on the edge of that edge, on the boundaries of that edge, are considered to be on that edge, and they were gone. And if we had a thick line that we're trying to draw, we basically had a huge gap at the ends, which we don't want in this case.
Oh, this is really
And this
cool.
solves that problem, right? Because the point that's over here, this point here, has a value of 1 because of the way that it's because of the way that we're interpolating.
Right. So since we're taking the previous approach took it out at the point level. It was like the barycentric coordinate was the notion of removal.
Yeah.
Which was the only information we had about the point. Oh, dude, this is clever.
Yeah.
Damn. All right.
So I don't know. Like, I haven't thought about it any more than this. I wonder if there's a way of just looking at the purple numbers without thinking about the derivation that we came upon and see if that just makes intuitive sense as is.
Right. That's really interesting that we can get away with just passing the single thing. Huh.
Yeah. Well, okay. I actually haven't told you the whole story.
Ah, okay.
Because if we're on, let's say edge A. Like, I remember how we said that the ordering of the edges, the labeling of the edges doesn't matter. So the question is, like, basically, how do you know whether you, like, which one of these components, interpolated component values, do you care about? Which are the ones you should pay attention to?
Right, because to derive the final value, we need to be really cognizant of winding in our setup. Whereas if we pass two attributes, we don't have to care as much. Right? Maybe not.
Sort of. Like, if we're actually writing a shader code, we're actually giving three interpolated values: one for A, one for B, and one for C. Let's say we're over here. We don't know in the fragment shader whether we're on A, B, or C. Like, that's not actually a piece of information that, like, goes into the fragment shader anywhere.
Right.
There's no labeling of edges in the fragment shader. But what we do have is we have one attribute value that's the value 1, and it's always going to be the value 1. You don't know that necessarily, but that it's always going to be that value. But at the current pixel, it's going to be 1. The second value is 0, and the third value is going to be something between 0 and 1. So the one additional piece of detail that I didn't mention is that what we're just basically trying to say is that if any component of this new attribute is exactly equal to 1, I don't care which one it is, then draw the pixel, right?
Yep, that makes sense.
And so let's actually take a look at edge B. We've got the A component is going to be some value between 0 and 1, depending on how close to point A we are. The B component's always 0 because it was pre-multiplied by a 0 value, so that's never going to be 1. And then the C component is going to be some value between 0 and 1, depending on how close to edge C you are, right? So I think the logic holds that if any of the components of this attribute at the current fragment wherever you're running the shader is exactly equal to 1, then you should draw the pixel, right?
I think that makes sense.
Yeah.
That's really weird.
Yeah. So here's another question for you.
All right.
What if we wanted a thicker line? What if we wanted the line to be a little bit thicker?
I was going to say, our approach of doing a threshold of like 0.04 still works, doesn't it? Like, it still work. Maps perfectly to this.
It does. Actually, I wasn't convinced that it would. I was a little bit worried about cases that, like, would we ever like draw a thick edge but then do this a little bit, right? Would we do that by accident if our threshold was too high?
Yeah, but we couldn't because the edge would be thick enough to cover that, because that value is not interpolating along the B line; it's interpolating the C line getting thicker.
Yes,
I think
exactly.
I think it's a safe wireframe.
Yes, you're exactly right. I think what you're getting at is the threshold that we're talking about it's a radius around a point on the line. And so if we had a radius around here, around like the corner down here, and if it's thick, that's fine. That's just the thickness of the line. That's what is exactly what we want. We're never going to have this kind of like weird wraparound situation. It's not going to be. You're not going to see a discontinuity. You're not going to see a discontinuity right here. It's going to be solid.
Well, right? Importantly for this one too, it's inside, right? We can't draw outside our own triangle, can we? Or can we?
No, we can't draw outside our own.
Okay, so it's like an inner stroke in CSS world. Okay.
Yeah. Oh, so you raise an interesting question, which is the fact that if we only do inner thickness.
That's all we can do, right? I think.
That's all we can do.
Yeah.
Correct. Which means that to use this particular technique, to draw thicker lines, we may need to add additional geometry in our post processing that adds a triangle here, so that we can draw the other half of the line.
Oh,
so that it's
that's an
equally
interesting
thick.
problem. Yeah.
Yeah.
Cross that bridge when we come to it. Now, is it equal thickness? It's just that we'll have an inner stroke no matter what. Like, not that we will not be able to draw a thick enough line. It's just
Yeah.
like we just have to be aware of that part of the technique.
If we do anti-aliasing in the fragment shader, the anti-aliasing is only going to work on pixels that are like up close to the line on that side of the line. Right.
Oh, that's annoying.
It wouldn't anti-alias outside here, right? Because the fragment shader just isn't running there unless we add that other piece of geometry.
Oh, fascinating. Yeah, okay. But that other piece of geometry is actually super easy. Like, we are basically going to pass another thing in there. We'd have to give it a different threshold. It couldn't be like... Or I guess we could evenly draw on each side of the line.
Yeah. And then this may be where like all the screen space partial derivative stuff comes in that becomes really subtle. This extra triangle here, like we have to figure out like what is its normal, like we just have to, the reason why we have to provide it is just because that's just part of the mesh, right? Like if all the surfaces have normals, you have to produce a triangle that has a normal on it, and you also have to provide a value for the point in the corner down here, right?
Yep.
So
Yeah, it's
like
tricky.
you have to make a decision of like, is it coplanar to this other triangle, and if it is, then
Well, that triangle is gonna give a very interesting bevel to the line, unless we do 2 to square it off. Right?
right.
So-
And we would have to know, it's another challenge is we'd have to know if there was already a triangle down here.
Yep.
Like the time that you would actually draw this is if like you actually had another triangle down there. Like think of the sort of corner of a cube. You may already have that triangle there that gives you the other side to draw. And you're right that there's a beveling problem, right? We're basically technically drawing 2 thin lines around a corner.
I was gonna say, finally, some CSS techniques that I understand.
Okay. Yes.
Because I've seen this shit before.
In CSS.
In CSS, yeah. But I am still interested in trying this as a shader and getting the inner stroke on the line, see what we come up with.
Yeah. So I'm going to leave that as an exercise for extra credit, because I actually do think that this is clever, but I think this double side of the line problem,
That's annoying.
it's annoying and challenging.
Well,
right?
and the nice thing is if we go through and do were we to go do this, if the code we're about to write that's going to be generate a line mesh from the triangle mesh, it's exactly the same code.
It's
Almost. It's
not exactly the same. It's the same business logic.
Yeah,
like find the coplanar neighbors, remove the edges that they share.
It's an identical algorithm to solve this problem, and then like the output values are different. So
Yeah,
I like that this is like remains available to us as well.
Yeah, I think let's like the decision on which strategy we end up using may be it may have been made for us already. So like WebGL line width. Let's actually do WebGL 2 line width because it's different.
You got the same results.
WebGL 2. This is a challenge in MDN. It doesn't have like a full index anywhere.
Isn't that weird? Well, now it's never going to get updated again, thanks to Mozilla being Mozilla. So, rest in peace.
Why are they bad? WebGL 2 rendering context?
Are you trying to suss out if we get anti-aliasing in this setup or not?
I'm trying to suss out whether or not we can pass a line width that is actually meaningful.
Mm-hmm.
WebGL line width. This is WebGL 1, so I'm assuming that WebGL 2 will be at least as capable as WebGL 1.
Mm-hmm.
The maximum minimum width. What the hell does that even mean? The maximum minimum width is allowed.
What?
The minimum maximum width is also allowed to be 1. Because of these implementation-defined limits, it is not recommended to use line widths other than 1.0, since there's no guarantee that any user's browser will display any other width. As of January 2017, most implementations of WebGL only support a minimum of 1 and a maximum of 1, as the technology they're based on has these same limits. So if we use...
1 is the entire screen, right?
Oh,
no, 1 is not.
1 is the pixel width.
Oh.
So basically what I'm saying is that... it's funny, you can actually... I'll give you an example. You get every color, you get every width of line as long as the width is 1. That's basically what they're saying here.
Ouch.
So if we wanted to do thicker lines for our wireframes, we'd have to do the shader thing.
Okay.
But I just think that the bevel thing that you were talking about becomes a challenge.
It's gonna be very annoying. Yeah.
It's gonna be annoying, right?
Boo. All right. Well, let's do the line mesh.
Let's do line mesh.
Yeah.
Okay.
Let's even see what we get, because we haven't spit out any GL line objects
Very
yet.
good.
Yeah.
Very good. I am enthused.
I am utterly baffled by that documentation for line thickness, though. Like, why, if it's only 1 pixel, why can I change it?
Yeah.
I guess you can make it thinner.
The WebGL spec. Let me try to parse this English here. The WebGL spec, based on the OpenGL ES 2.0 and 3.0 specs, points out that the minimum and maximum width for a line is implementation defined. Okay, so they're talking about restrictions on the range of line widths for implementations. And the spec says that the highest minimum value that you can have is 1. And because you may want to go over that. But you can't. You have to at least allow a minimum of 1 and no thicker than that, right? Because you may want to implement something that only does line widths of 5, but no. The highest you can go for the minimum is 1. And the smallest maximum is also 1. So basically what they're saying is like, why even give this function in the API, right? They just like added it in there, and then it literally does nothing.
Yeah, I do see on WebGL 2 fundamentals the ability to get the alias line width range as a min-max assignment. And I assume it returns back the value 1 and 1.
That's cool.
This site also is pretty down on it.
Yeah. That site's great. The WebGL2 fundamentals, which did the state diagram thing.
Yeah.
Also, the same author actually did this presentation that everybody quotes, but it's from 2011, so it's from way back in the day when I believe he was working on the Chrome WebGL team. So he's in the know. He's pretty close to the, pretty close to the belly of the beast right there. He basically did a presentation about how you can maximize or optimize draw call efficiency, all the kinds of things that Steve was talking about, but for like a specific WebGL context. And I learned a lot, and then I realized he wrote the WebGL2 fundamental site, including that like state machine thing that we used. So that guy's like the premier WebGL educator out there. Probably up there with the learnopengl.com guy, but probably more relevant to our use cases. And everything on that site is good.
WebGL 2 Fundamentals is like actually a perfect website. It's like well documented, well written, and it has that really cool state diagram.
Yeah, and this really awesome background.
That animates pretty well.
Everything in here is awesome. He talks about we can go on this little tangent here that I've been going on this entire time.
Oh yeah.
He talks about Steve had kind of hinted at like somehow doing animation like matrix multiplies for the vertex shader, but on the GPU side. And I was like, what are you talking about, Steve? How do you do that? And he didn't have time to explain, but there's a whole article on skinning
Cool.
and it's brilliant. This is all like animation looking stuff, right? You got a bone. The bone is just we've been calling it like the transform on a node, but a bone is
But it's a
essentially the
bone.
same.
Yeah.
Yeah, it's a bone, or rather, the bones are just matrices. Or basically, what you do is you load all of your bone matrices into a texture. And then WebGL2 lets you read from textures in the vertex shader. Now, normally you think of just like textures as like some kind of color, or at least some kind of like pixel level information, right? But this is really cool, where it's just like, actually texture is just another piece of random access memory that you can read inside your shaders.
Man, I saw a thing about the PS5 where they were like, we added this really cool 3D audio processing unit, and they took it to game devs, and they're like, great, we'll run our AI through this. And I was like, what the fuck?
Right. There's a term called GPGPU, which is the general purpose GPU, which is the idea is that you're using your GPU for non-G stuff, non-graphical stuff. There's a whole toolkit called CUDA, CUDA.
Oh yeah, I've seen that. Yeah.
Yeah, that's basically about NVIDIA's kind of like an interface for just, you want to do a ton of vector processing. You want to do a ton of parallel processing on hardware that is like specifically meant to do a bunch of like parallel matrix multiplies. Here you go. Right.
Gotta mine some Bitcoin.
Yeah.
Which, is that good, or is that just someone getting really clever?
I don't know. I think at a certain point, like maybe CUDA is just like a nicer interface.
I'd say there is a CUDA Bitcoin miner. Yeah.
Yeah, there you go.
Fascinating.
I think with Bitcoin, they've gotten past that. They're just like, no, why are we using GPUs when we could like actually build in Verilog, like a SHA-2 hasher, something like that. And that's what the ASIC is all about. What is ASIC? Specialized integrated circuit or something like that. Yeah.
Wait for the M2 that comes with the built-in Bitcoin miner.
Brought to you by 21. Okay, so we want to do some geometry analysis. Let's just do the whiteboard really quick, just to talk about the general approach to the problem.
Yeah, because we've been talking about this from a purely one triangle at a time, but to be able to look at multiple triangles in our system, we actually don't have a good primitive for that yet.
Yeah, we talked a little bit about it with Steve, but let's say you have triangles that share two vertices, okay? So there's a whole like sorting and looping iteration problem for us to maybe try to make that not an n squared problem. Right? So that's a fun little computer science puzzle. Two, I guess we just emit line geometry. For all edges, except, I don't know why I wrote it this way, but what's the exception here?
Except if it is shared by two triangles with the same normal?
Yep.
This actually is maybe pretty nice too, because our triangles are all in our index buffer, and we could pretty easily look and just see like, oh, who is like who no, we can look at the instances of a vertex in the index buffer and describe triangles. So maybe this ain't terrible.
What's nice about the geometry that we're working with is we actually have the normals already. We don't even have to calculate them.
Nope.
Right.
Are we guaranteed, by the way, that every point on every triangle has the same normal?
Do all the verts have the same
Yeah.
normal value? I think that's the case, or they're very, very close to the same value. If they were actually literally different bits, I'd be very surprised. You would
Yeah.
think that would be like kind of like a core property. I actually don't think that two neighboring triangles that are conceptually supposed to be coplanar will have the same bits for their vertex normals because of floating point error, right? Because how are they going to calculate those normals? Well, they're going to take you can pick two vectors on this thing, any two of them. This one and this one. And you take the cross product of those two, right? And then that'll give you, it's going to be really hard to draw, but kind of something projecting normal, like upwards towards the camera.
Yep.
That's a terrible drawing. Yeah, like it was even worse than I thought it was going to be. Let me make one more. Let me make one more attempt.
Drawing 3D and 2D is just the ongoing challenge of this thing, though. Yeah.
That's a little bit more legible. You take the cross product of any two consecutive edges. I guess every edge is consecutive on a triangle, right? Like, you ever do the thing where you're arranging keys on your key ring, and you're like, this is just me because I'm kind of like psychopath.
I'm trying to remember the last time I arranged
like,
the keys on my keyring, but like also my keyring is a mess, so maybe I'm the problem.
I don't know. Like, I used to have a key for like work, right? We used to work for small companies where they would give you a physical key for the door, right? And I would like arrange them, but sometimes I'd only have 3, and I'm like, is there a way that I can arrange these so I can kind of tell that I put some of the keys close together or whatever? And then I realized because I had 3, there was no way, because they're all adjacent to each other, right?
Yep,
So
that's funny.
You pick two edges, and as long as you cross product them in the right order, you will get a normal. Like you should get the same normal value for all, for every pair of those, right? And that computation is in floating point. Then you got to normalize it or make it a unit vector, which is also going to make it not equal. In fact, I don't know if the geometry does the normalization for us. So that's another open question, right? So that means that if we're trying to determine whether this thing right here, if they share the same normal, that can't be a strict equality. We're going to have to do something a little bit smarter for that.
And we've got our lovely vec2, vec3 equality functions that are doing like the iffy equality, right?
Yeah, I guess normalization matters here, though. Like, we could just normalize the two normals if we assume that they're not unit vectors, and then do your equality that you were talking about. The other thing that that Steve had suggested is we're going to have another normal over here, right? And it could be like scaled really weirdly, right? It could be like really long.
Oh.
I don't know why
that'd be surprising, but
it'd be surprising. You would think that you would just want your program, your modeling program, to just emit that for you.
Yeah, but I've been surprised by so much stuff so far. So
yeah. The other thing you can do is like I believe I think you still normalize them. I guess you just normalize them and check for equality within a certain deviation, or you normalize them and then take the dot product of the two. And if the value of the dot product is very close to 1, then they are coplanar.
Oh, right. Okay, that was a suggestion for exactly that reason. Yep. Okay.
Yeah. What is the dot product? I know that the cross product, like the magnitude of a cross product.
I know, and you said cross product, and he was like, "Oh no, don't do that," and I was like, "Oh no, I don't know why."
Yeah, I didn't know why either. Right, you have some angle here at theta. Right. Like the magnitude of the cross product is the area of the parallelogram bounded by the two vectors that you're crossing against each other. Is that correct? Does that sound vaguely familiar?
That sounds vaguely familiar, but oof. I feel like this is what I'm going to learn this week. Dot product.
And then the dot product, I believe, is you take the projection of. Sorry, you can't see this.
Oh, thank you. Yeah.
you take the projection of A on B, so this one, A prime, let's call it. And then you multiply A prime, like the distance of A prime times the magnitude of B. And that is the value of the dot product. Now, the intuition there is if you normalize those two first, then A and B are both 1.
And you get one out the other side.
You get one out the other side if they are parallel. If they're not parallel, then A prime is going to be some value that's less than 1.
Yep.
Right?
Yep. Interesting.
And if A was perpendicular to B, then actually A prime times B would be 0, right? Because they'd have, like, there would be no projection of vector A onto B. They're orthogonal. That's literally, I think that's the core definition of orthogonality, is that, like, A has nothing to do with B. There's no part of A that is composed by any part of B. Okay. So should we do it?
Absolutely.
Okay.
I mean, let's start. I think looping through our geometry is probably going to take most of our chunk of time tonight.
Yeah. Boy, we are really masochists about this.
I know.
And I'm glad that you're with me on this ride. Because we could just be plugging this into 3JS and just, like, chugging our way to riches and fame.
As much as it makes my brain sort of, like, hurt, I really enjoy all this, though. It's the good kind of brain hurt.
Yeah. This is the character building kind of brain hurt,
yeah.
Right?
My math has definitely, like, come back this year, and it's very pleasant.
Cool. I always have this plan of, like, going back and, like, actually working through a linear algebra textbook, because I never did it.
Friggin' same.
Yeah. Wait, you must have, though, right? You went through like
oh, I did it, but like it didn't stick. It's just like there's been no reason to use it for years, a decade.
Can I tell you? You know how we talked about Jordan Mechner in the past, the guy who made Prince of Persia, and how he spent the entire time, or most of the time that he was working on Prince of Persia, just like one of the great games of the industry.
So good.
Right? Like it spawned like every kind of like Tomb Raider-esque game, you know, just like exploring a world and solving puzzles. This just basically comes from Prince of Persia. Anyways, he spent the entire time when he was working on that game, like thinking he was going to be a Hollywood screenwriter.
That's so strange, man. What a weird concept.
Yeah, and he's like, you know what, this is not my main thing. And I remember in a very extremely more mortal and mediocre version of that story, when I was in the game industry, all of this stuff that we're working on right now was like 2 or 3 levels of abstraction below the interface that I worked on, right? It's like being a front-end programmer, and like you can be an awesome front-end engineer but never really know how stuff is getting painted in the browser, right? You know, you're working on the level of like, I need this button to have this side effect, and I need to organize the code in a way that like my 3 junior engineers can handle it. And that's a whole different problem set.
You don't have to build the browser, which is what we're doing.
Exactly. But I remember I had an office mate at the AAA I worked at who was an animation guy, and I didn't learn a single thing about animation from him. I like had lunch with him once. Basically, he was very quiet, granted. And he's very tall. His name is Keith, and apparently he played baseball in college. But then was just like this like kick-ass animation programmer, and I didn't learn a single damn thing after like sharing an office with this guy for like 8 months. So yeah, it's a total bummer. But at the time, I thought I was going to be an academic, or I thought I was going to be a writer. You know, so like I was like, you know what, I'm just like making my coin here in the video game industry, and here I am, idiotically, 12 years later, like learning all this stuff again, you know?
You know, it was really funny. After the Puzzle Hunt wrap this weekend, everyone was like, that MMO is really cool. Like, we should all make games. And I was like, yeah. Yeah, we should.
We should. Oh, man, I've been watching the No Clip documentary on the making of Hades. Do you know No Clip?
Yeah, but I didn't see that documentary. Is it good?
Okay, it's a 5-parter, yeah.
5-parter. Wow. That's a lot. Really that's a lot to say about Hades. I like it.
Yeah, I mean, I think there's a little bit of padding going on. Like, I'd say the episode I just watched maybe wasn't super necessary, but they talk a lot about like, it's actually really kind of more about the human process of making the video game.
See, that's great because I really want to know more about that team in particular.
Yeah,
Like it's explicitly
they seem really great, awesome to work with.
Yeah, how do I get hired by them? I probably have some actual skills.
Yeah,
I'd make their website for them.
We could get hired by them, or we could make something as cool as them, right? Or we could make something. We can make something. Period. And I think we can start there.
I think we actually have quite good game design sensibilities. I think we could pull off something pretty delightful.
Yeah.
And
if
and
only
are
we
doing
could get
it.
anything to fucking draw, right? That's
At some point, we are going to do the version of this where we like use an engine, and it's also going to be really fun. So whatever.
Yeah. I don't know. I think when I'm on my deathbed, I will want to have known that I did it my way.
Oh yeah.
In the Frank Sinatra sense.
Did you write a kernel in your like OS class at all? Did you ever have to do that?
We kind of did, but it was in Java, so
Oh.
it was a little bit hard to know what was the difference between.
Oh, you didn't use like the fake microcontroller architecture, or maybe you did, but in Java.
I remember it being really weird because it simulated parallelism by running on Java threads, and I was like, "Wait, why are we?"
Oh, no,
It's
no.
really weird
Yeah.
to do that, right?
That's
Like,
very
yeah,
strange.
And it was. I don't know. I hope they don't do that anymore. This is the UC Berkeley operating systems class. I really hope they don't use that.
It's weird. I don't like that.
I don't like it either. And it was like again, like 15 years later, I took an OS class like after work. It was just like a month long, and I was like, this is so demystifying. It's incredible.
Yeah, I very much remember writing the like file the disk page manager, the memory page manager, and all that stuff.
Yes.
And like process switching and fork and all that, and it was great.
Yeah, I was gonna say, like, once you get like the memory manager, that's the thing that kind of just like opens everything
Yeah,
up.
write
right?
your own virtual memory, and you're like, oh, this is what it is. Great.
And it's crazy. Like everything comes from that, right? We were talking earlier today about how, like, how does our M1 Max, how does it transform the Intel bytecode that the JavaScript engine emits into ARM code? Because you can get it, you can kind of imagine how it would do with the executable, like the actual like node binary.
Mm-hmm.
When you tell the OS run this binary, it just looks at the binary and says, "Hey, this is actually written for Intel. I'm gonna basically just convert the whole thing into ARM64 right now. Go." But the problem is that binary itself spits out Intel code because that's what it's doing with the JavaScript that it's running. And then it's like, well, how does it do that? Well, it's because it can mark the page of wherever the JavaScript code or whatever Intel code it just generated. It can just like mark that as executable code, and the operating system will intercept that because it can like do these things and say, actually, you know what? While you're doing that, I'm gonna go behind the scenes and convert this into something else.
It's so damn clever. Yeah.
It's amazing. Yeah. They're pretty good in the 70s. They knew what they were doing. How do we want to go about doing this? Should we make a different library? This may actually be something a little bit akin to like quad tree, where maybe we want to do this in the context of unit tests rather than.
Well, there's that processor file that's just sort of hanging out there waiting to be, like there's a function for this that I think we could move it out, but it definitely is like in a unit testable spot right now.
Okay. Oh, this is nice.
Yeah.
So it does it per node.
Yeah. Well, and if you look at the pass-through processor, it's meant to be recursive as well. So like, you just keep passing it through.
Okay. I didn't know you could do this in JavaScript.
I hope you can. It looks like it worked. It's stuck.
I'm pretty sure you can.
Yeah.
It's not complaining. The type checker's fine. It's just something I learned. Okay.
So
we're gonna do this we're gonna do it actually mesh by mesh. So
Mesh
we're
by
creating
mesh.
a new node, but what we're actually doing is we're saying
I was gonna say you could actually maybe copy some of the pass-through stuff as well, because really, when it gets to the mesh, it just copies buffers.
okay.
So I think everything else about the recursion is probably still valid. And then it's
so rather than get GL buffer,
yeah.
What we're gonna do is we're gonna make a line mesh from a regular mesh, right?
Mm-hmm.
Does this disgust you if I wrote my function this way?
No, I kind of like it.
Okay. It's just in the muscle memory.
Mm-hmm. No, I've noticed that you have some of the like game dev terminology under your fingers still, and it's I'm a fan.
Oh, okay. What I meant was that I'm making the function using the keyword function as opposed to
whatever.
Okay.
Is that a problem? I don't think so. Who's gonna know?
And we're returning a model node or a render node?
That's a great question. We're returning a render node. Yeah. Because the model nodes contain JavaScript values. Render nodes are meant to go to the renderer.
Yeah. What this is it's gonna bake in two steps. It's gonna do the triangle to line conversion with edge removal, common edge removal, and then it's also going to do the GL loading as well.
That's correct.
Yeah. Okay. And it's meshes that we want, right? Is this model? What's the equivalent of this? What does a model node even have in it?
Oh,
a data mesh.
Data mesh, yeah. Data mesh and render mesh are the two. It's a weird place to have split, but it made it really easy to work with.
No, I think this abstraction makes sense. Data is just what JavaScript can access. Render meshes, it's got some GL stuff in it. Exactly the problem that we were talking about at the beginning of the stream.
Yep.
Okay, so the new mesh is basically going to be the result of us calling try mesh to line mesh of model. Is it M?
It looks like it is model.mesh, yeah. Yep. And I'm sure you'll need the
What
GL.
am I looking at here?
The type signature. Model and GL are the parameters.
Oh, is this the same thing as if we did this? Is that the same?
Oh, yeah, you know what? It totally is. I don't know
Okay.
I don't know why my brain farted that way. Yep.
Cool. Okay. And then I wrote it like yet another way over here, just because that's fun.
Some real Ruby can do anything you want energy going on.
Render mesh. We're not really going to go straight to that, though, right? And then this is not get GL pass-through mesh, but it's get GL line mesh, right? And why is it complaining? These are all M's.
Line 6, yeah, or use model. Yep.
Okay. So now this is where the real meat of the problem is. So what are we going to do here? Source. I just want to take a look at this data structure really quick.
Totally.
No definition found.
I bet you would like to take a look at it. There we go.
It is either a line mesh or a triangle mesh. So this should actually literally be one of these, right?
Yep.
In a render mesh, I believe we thought. Come on. Is that not auto formatting? I feel like we're definitely past.
Oh, just return type. Line 21 is going to be a little annoying, but you could do if m.mesh not equal null and m.mesh.primitive equal triangle. It's mesh primitive, yeah. There you go.
And this is not equals undefined. I think this is one of the comments I left in.
Oh, I thought, since it was allowed, I assumed it was passing the new system.
I don't understand it myself, but
Yeah.
it's a question mark, and that to me means either
No,
it's
totally.
one of the things. Yeah, it actually the null comparison I thought the linter would catch, but
No,
it didn't.
the type checker should have caught that
Yeah.
too. Maybe you can fix that in the pass-through renderer since that line is
Yeah, I mean,
exactly there.
really, I think probably what we should be doing here is if the mesh is not undefined, if the mesh is not triangles, we should be throwing an exception here, right?
Yeah, totally. I mean, I guess it's sort of a question of like, it could also just not assign a mesh for this. If there's line meshes inside of triangle, like, depends what's in the GLTF file since it can contain both.
I think you
Well,
should be intentional. I think the caller of this function should be intentional, right?
Yeah.
Like,
And as I say, it's nice because we're only going to feed it with triangle meshes, so we don't
Yep.
have to think that hard.
look, I'm using the new thing already. I'm addicted to it.
Nice.
Okay.
It's fun to blow up a program.
And then a triangle mesh is a bunch of buffers.
That are buffer arrays.
Yeah. How much do we care about navigating the differences between these different types? Pretty much it's always going to be
I think
float 32 arrays for this,
Yeah.
float 32 arrays for normals, and then uint 16 arrays for the indices. Right?
I don't particularly care. I think when we have a model that has it different than what our processor expects and we fail to render correctly, it'll be very obvious that we need to fix that particular problem. But
Okay,
like right
cool.
now, I don't care.
All right, sounds good.
Yeah. Yeah, it's interesting. The generic I put on for buffer array maybe makes that a little complicated. But buffer array.
Well, I think you were actually adapting the code that I had there before.
Yeah, yeah, totally. It's so that it can actually accept a GL buffer as well for this structure.
Right. But I left a comment in the PR that your refactor makes it obvious that these two things are potentially redundant, right? Because I think every value of this enum, because it's one of those accessor component types that we spent some time refactoring at the very beginning of the stream, which so it's like either a byte or it's a signed 16-bit integer or something like that. Those all have corresponding values in one of it's basically one of these things.
Totally.
Right. However, it may be more convenient to like switch off of this because you want to do something specific, right? It may be good to know.
Yeah, I can imagine actually, stepping away from generics and having a data buffer in a GL buffer format that's more specific. So,
okay,
totally.
No worries.
Yeah.
So source, we basically have to iterate over all of our triangles, which are basically specified by the indexes, right? And in our line mesh that's going to come out of this is potentially going to have, it's definitely going to have fewer indexes, right? If we're indexing. But it will have exactly the same number of positions. Is that correct?
Same number of positions. Yeah. Well,
Not necessarily.
yeah, anything that's on a vertice that's never rendered won't be in that list.
And then we don't have normals anymore, right?
No.
I guess we could keep the normals if we wanted to do something funky with it. So
That's interesting. Yeah.
I think we're not going to have the same number of normals or positions because we could have a fully interior triangle on a surface, right? Like a surface could have like a fully interior triangle where none of its vertexes get rendered, right?
Or even if we were to do like, if you rendered like a hexagon in triangles,
Yeah,
you've got one point and vertex that is gone.
correct. Yeah, that's a really interesting point. Okay, so what we need to do is we basically need our algorithm again, if I can find it. triangles that share two vertexes. So couple different ways that we could do this. We could create a bunch of triangle objects and stuff them into, or stuff pointers to them into like a dictionary, a map of, well, okay. One thing we could do is we could just say, let's compare each triangle to every single other triangle.
Yeah. I'm like trying. It's like it's on the tip of my brain. It's like if we inserted triangles into a hash map based on their vertex.
Yeah.
Like if we inserted everything in the hash map 3 times, once for every vertex it's shared.
Okay.
That would actually be a really easy way to index into this.
What happens if the vertex positions are not exactly the same? Will we need to round them?
Yeah. Right. I forgot that every triangle vertexes aren't shared. Yeah. Never mind.
Well,
are vertexes shared?
Well, because we're using the index buffer, they should be shared.
Yeah, I was gonna say it should be as optimal as it can be, right? I was gonna look at the data. I don't know what's in the GLTF buffer.
Yeah, I mean, ideally, like Blender had figured it out and like is not giving you any redundant vertices. So maybe we can rely on the fact that the numbers are exactly the same.
I guess the thing we've seen in other models is that vertices are duplicated so that the normal buffer can be padded to the same length. And I wonder if it's doing that or not. We don't really know what the format is.
Yeah.
Okay.
Okay. So basically what we're saying is like fill hash map. What are the keys?
I was thinking they were indices, but
or an index. You're right. You're absolutely right. It could just be in the index because the index basically tells us whether. Oh, this is great. The fact that we're using an index buffer actually makes this a lot easier because we don't have to like figure out an encoding format. We just have integers, right?
If it's not duplicating points, yeah, we're good. If it's duplicating points, I think filling by index is maybe nonsense. It doesn't help us find adjoining triangles.
Oh, and I was going to say that one of the problems is if the vertex normal was different, because the index would then be different. But if the vertex normal was different, then we probably want to keep the edge, right? So the map is a vertex index to triangle, which is some pointer. Okay, so we fill that map. Now, what do we do with that map? Iterate. So for each triangle.
Are we going to loop over every index? And I guess it'd be nice to have. It'd be nice to have, like, if the triangles were a little structured, to be able to mark them as compared or not.
Right.
This is a lot.
It's interesting though, right?
Yeah.
I think we can kind of like grind it out. Let's say for okay, let me do this the super dumb thing, right? So for each triangle T, for each vertex, or really what we want is for each edge V1, V2 in T. You see how Python kind of came about? It's basically they really want,
I mean, I love Python. It just doesn't have enough useful bits attached to it for me.
Look up fill map M. Look up V1 in M. Let's see. Tries 1. V2 in M. do tries one. This is the set union. Union tries, or intersection, right? Minus t. So your set, and if set non-empty, then v1, v2 is shared. Does that make sense? Basically what we're saying is that, like, give me all the triangles that have v1 in them. Give me all the triangles that have v2 in them. If there's a triangle that has both of those, it'll be in the intersection of those two.
Right. Okay, yeah. We're just getting shared vertices. Yeah, totally.
Yeah. And then we're going to remove the triangle itself, right? Because, like, the triangle that we're on is gonna be in that list. We're guaranteed that this intersection has at least one triangle in it. Or we can say if the cardinality of the set is greater than 1, then, and we don't have to worry about the subtraction anymore. I kind of like this algorithm. It's not that bad, right? And the nice thing about it is that v1 and v2 are just indexes into the index array. They're literally like, and then I think that'll do it for us.
Yeah, I think this actually works pretty well.
Because we know, well, then we have to check, and if they're coplanar, that means the normals will be the same. And if the normals are the same, then yeah, so I actually don't think we have to worry about, like, doing any math here, as long as we assume that Blender is doing the right thing and being as minimal as possible.
Yeah, I'm still a little worried about point reuse. I guess, yeah, I wonder if indices will be reused if they're coplanar and not reused if they're not coplanar.
I see what you're saying. Yeah, I see what. Yeah,
and if they are coplanar, they actually can be reused because the index buffer can go back and look at the old normals too. So
I think the thing I'm worried about is if the coplane, whatever Blender or whatever 3D suite that we're using. What if it doesn't do vertex reuse if the normals are slightly off? That's the thing that I'm worried about.
But see, I think that actually, like, looking at our tank, it's actually fairly, like, it's a low poly model for sure. I think it has a lot of flat faces that actually are flat faces, and the turret even more so has giant quads. And it's like really made of some primitive. So I think part of this too is going to be like, yeah, if it's not coplanar, if like one side has a little bulge in it, like I think we actually fix that in the model side too. Like we're gonna make simpler models than this one chunky tank. So
well, let's do the simple thing right now.
Let's see how it
and if
comes
we
out.
Get into a situation where the 3D export is, even though things are coplanar, but it's using different vertex indexes because the normal value of that vertex or the position value is just like ever so slightly different than another one, then we have to be a little bit, we actually have to start to do the math. But before we get to that point, let's just assume that it's like perfect.
I'm optimistic. Let's see what we get.
Okay. And then for T, okay, so this tells us which edges are shared. And so what are we doing actually? Do we actually have fill set with all possible edges? And then is it here remove v1 v2 from draw set?
Yep, totally. And then our draw set is what we spit back out into the mesh. Yeah, totally.
Okay. Or what we can do is we fill the set as we're iterating over triangles. Or we could do this, like add v1, v2 to negation set or something like that. That's another way we could do it.
Does it make sense to just add to the draw set if it's not shared? Because then we don't have to like line 4 actually seems like a bunch of pre-processing work to enumerate the edges versus
Oh, I see what you're saying because
like if it's not
we will know
shared.
everything. We know everything about like I was assuming that we didn't like it would change over time, but like I actually think once you've filled the map, you know everything. You have like a complete information about the
Yeah,
whole.
and
Okay.
every edge is only between two triangles, so it's on or off, and we have all the state here. I think yeah, yeah.
Okay. So how do we get triangles? This is what we need because to even fill the map, we need some notion of a triangle, right? So we iterate over every 3 indexes.
I think that's it. Yeah,
Okay.
yeah, yeah. I wish we could do. I wish there was a JS iterator that was like iterate, like pull a bunch at a time. There's like a Ruby sample for that, I think. But
Okay.
yep, what you're doing is definitely correct.
For const.
Oh, actually, no. You could do a for loop with I and do I plus equals 3. And we'll just take I plus 1 and I plus 2 out at a time. Is that crazy?
Yes, I think I see what you're saying. I less than source dot indices dot length.
That buffer dot length.
We don't want the buffer, and then this buffer is
This buffer is a JavaScript buffer.
uint16 array, right? Okay, I plus plus. And it's actually I plus equals 3, right? Right.
Yeah. It's better than having keeping track of like an accumulator of like points and then splitting it out.
And then the triangle name is just gonna be I, right? And the triangle names will just have a gap of 2 between them. Is that fine?
Yeah.
Okay, great. If we need a triangle name here, and we need a triangle name here because we have to actually generate the edges, right?
Oh, interesting. Yeah. Okay.
Okay, so for each one of those, what are we doing? We're filling the map, right? It is a what? Number. Doesn't like that.
Wait, is it
never
not
used? Okay.
Is it not a index to triangle? So the first type should just be number, right?
Oh, you're right.
Yeah.
Shoot. Okay. Okay. So this is actually fun. This is basically going to be tries by verts dot add, or rather, wait. We need to actually const list equals tries by vert dot get of the vertex number is source.indices dot buffer of I, right? Or is it just I?
Oh, I'm not sure.
It's this one.
It's gotta be that. We don't know what. Yeah.
Yeah.
Okay.
This is a let list. If list is undefined, list equals an array, and it's actually an array of tries by vert dot add. Wait, is it set? So let me do const vert is source.indices.buffer I, and this is going to be a lot easier to read once I do this. Yeah.
Yep.
Set vert list.
Set vert list. Okay. What's that unhappy about? Oh, const. No. Oh, list is already typed. You don't need to do that. It's typed from the get.
Nice.
Yeah.
Then we do list.push. I. So this time we don't look into the vertices because we basically want to like number our triangles. If we wanted our triangles to be sequential, like the triangle like names to be sequential, we just divide by 3.
I'm okay with that. Yeah.
But we technically don't have to. It's not 100% necessary.
So it's okay. So we're on triangle. We're on triangle 0.
Yep.
We're at the first vert and we're pushing triangle 0 on it. We're gonna push 0. We're gonna push the triangle index onto every vert, onto vert 0, 1, and 2 for this triangle. Okay. Yeah, I can see that.
Cool. Or for verts A, B, and C, which are the first 3 in the index buffer, right?
Yep.
We don't know if they're actually number 0, number 1, and number 2.
Totally.
They're just A, B, and C.
So actually, we need like a little. We need a little loop 1 through 3 inside of this. That's like for each vert in this triangle for the index because we're jumping 3 at a time.
We do. Oh yeah, we're right. Oh yeah, you're right.
Because that's on this triangle, so we're keeping our triangle index. I'm
right.
I'm open if that is too weird to count. I'm open to another way.
I think that's what we could do is go vert by vert, and then what we'd push is like integer division by 3. That's the other way to do it.
Okay.
How do you do integer division? Math.floor of I divided by 3.
Yep.
Is that right?
I think so.
Okay. This is making a little bit of sense, right? Gonna give it a nice little name. What if we did this? Is that crazy?
No, I like sets.
Set of triangle indices, right?
Uh-huh.
And it's not an array anymore. And then add try.
Yep.
So far, so good?
So far, so good. Big fan.
Nice. Okay. Now, for each triangle T, for let T equal 0, T less than source.indices.buffer.length divided by 3, T plus plus. Sorry, this is T. Doesn't this feel like we're writing C code a little bit?
It really does. It's been a minute.
It's all like array indexes. That's what C code is basically.
Yeah, I was gonna say the only thing it feels more like C code is the actual shaders.
That's true. Although the shaders don't have pointers and stuff like that. If this was actually, I take it back. If this was real C code, we'd be doing like star P++. We'd be doing something like completely horrible. Yeah. All that ridiculous golfing that people would do in their source code. Like I bet people like who write in the Linux kernel still have this kind of like bravado, this machismo about this. It's like how many pointer operations and pointer reads can I bake into like one line?
I gotta tell you, I have not had that feeling until I tried to do some Rust, and I was like, why am I passing everything as like an ampersand or something or a star?
Yeah,
it's bizarre.
At least Rust doesn't have pointer arithmetic, right?
Yeah,
like
thank goodness.
This whole like people will literally do this in C programming, and they're like, because I can read this, it's good code. You know what I mean? That whole attitude. Ugh.
Yikes! I have never gotten that far into C, and I am grateful.
Okay. For each edge, V1, V2 in the triangle. Okay, so for each edge. Of the edges look like this, basically. Source.indices.buffer of T times 3 plus 0. This is going to be horrible, but bear with me here.
Oh, yeah, but it's like, we just have to do it. I don't think it's worth building the triangle array in advance, so this is better.
So, okay, let me try to break this out. So this is the first edge. I think I have too many of these, right?
Oh, I see what you're doing. Yep.
Okay, that is...
Do we need a V3 in here?
We don't, because we're just looking at the edges, right? So we're saying for each edge, V2, V1, V2 in the triangle.
Oh, but it's just we're taking V1, V2 of a 3-element array?
Oh, I see what you're saying. We need no, but these are vertexes, right? These are just vertex numbers.
But what's the third element for then?
We have 3 edges. This is the first edge. So imagine that the vertexes are labeled A, B, and C.
Okay.
We need edge AB, we need edge BC, and we need edge CA. That's what I'm going for here.
Gotcha. Okay, yep, with you.
Actually, let's.
I would say we're gonna do this 3 times then, so maybe we just assign that.
Actually, why don't I just copy this out? Right, that's what you were saying.
Yeah, because we're gonna use this repeatedly. And that's gonna make this a lot clearer. Cool. Oh, and now I see, because we're iterating through edge pairs. Yep, sorry. Now I get it.
No, I think I could have just started with this. This is just where my head went initially. So what we're doing is we're saying const tries 1 equals... Was that your cat?
Yeah, dude. Just makes that noise all the time. Nope. Tries by vert v2.
Oh, this is .get.
.get, yeah.
And we're going to assume these are undefined, right? Is that fair to assert that they have to be in there?
I think they have to be.
Okay.
At this point, yeah.
Yeah. Tries 1 dot difference. Is there no set arithmetic?
Is there not set union in...
Oh, you gotta be kidding me. Oh, I actually think this is why Lodash, why people use Lodash, right?
Bro, that's just hilarious. I love it on MDN. There's like a implementing basic set operations. Why are we using sets at all?
You know what? Whatever. We're programmers.
No, it's great. It's fine. I copy paste code with the best of them.
Yeah.
But also that's hilarious.
Intersection is a set T. This is actually the result. Let's just rename this to A. Let's just rename this to B. And there we go. We shall never speak of this again. So really what we could do is we could just say, if the intersection of tries by verts of get v1 tries by verts got get v2 exclamation point intersection dot length
Dot count? Dot
size?
Yeah.
Is that a function? Is size is greater than 1. Oh, then we're basically don't do anything. So what we actually want is const visible edges. And that is a set of number. So what we're saying is if it exactly equals 1, then visible edges dot add v1, v2. And then so this is not so bad so far. It's making some logical sense. Now we've got visible edges, and now we need to make a bunch of indices, right? So const indices equals new uint16 array. Can we push on these? I don't think we can.
No,
right?
uint16. We should make an array and wrap it in the uint16 array. That's like I feel like that's the JavaScript solution. It's because you can only write memory like bytes into it.
Yeah, and we don't need this to be perfect up front, right? So, okay. So the indices, wait, should I just make indices rather than doing visible edges? Because the indices are really just going to be like pairwise numbers, right? So maybe that's...
Oh, yeah. And just push?
Yeah.
Yep.
And then we
need to output, so we've got our index buffer, but we need a new vertex buffer that is just...
and a new normal buffer as well.
We don't need a normal buffer. I mean, we don't want... Do we need normals for our lines? I thought you were saying we're just not going to use them. Kind of depends if they glow or not.
I think if we want, I think we might want to light our...
Yeah, it might be nice to have lighting. Okay. Then the normal buffer is the same thing, so yeah.
Well, I don't 100% know, but you're right, it's going to be the same thing. So here is what's interesting. If we remove stuff from the normal buffer, the position buffer, the indexes change. So one thing we could do is just return the same normal buffer and the same position buffer, and just let it be bloaty.
Oh, that's funny.
Which I think it's fine, right?
Yeah. Cute. I like it. So it's just a new index buffer. Oh, that's really funny.
So this returns a render. What does a line mesh look like again?
Very similar.
Okay, so it's just this.
Yep. But so, yeah, that result is good. But then we're going to need to convert to GL buffers at some point, which probably shouldn't be here. Yeah. Could be here.
If you don't want it to be here, we could make this...
Oh, sorry, we're turning render mesh. No, you're totally right. Yep.
Yeah, I mean, that's what I meant when we were like starting this function. I was saying we're actually doing two different things. We're kind of like...
Yeah, but...
one of these and then...
that's okay.
And then, well, don't we have a function that does this conversion already? In the processor?
It's in the pass-through, yeah, which we could... that function is pretty generic, I think. Yep.
Okay.
Very generic, actually, because it even does the right buffer types. Yeah. Processor common.
You okay?
Yep.
Sorry, I just heard a yelp.
I heard that too, and you don't
probably meant there was a spider or something like that.
I was gonna say you don't still have a dog, do you?
No.
Yeah. I heard a yip, but spider makes sense.
Why don't I do this? Why don't we do the conversion over here? And I think that'll make this function a little bit more nicely self-contained.
Okay.
So this is a data mesh then that we're returning, right?
Really, we just need to return the new index array, right? It's like just an array. Since we're not modifying the vertex or the normal buffers, which is very clever.
You're absolutely correct.
No, I love
so
it.
You're just, and so what does that mean? Do we only pass? I think we only read the indices anyways, right? So do we just?
I mean, whatever we were using, we're just going to feed the exact same. Yeah. This is fine.
Yeah, we're taking the liberties here. We're assuming that our 3D software is doing the right thing here and not doing anything too.
I think it's a pleasant assumption, though. It's going to save us a couple headaches.
Try indices.
Mm-hmm.
It's great.
Hell yeah.
And so...
Okay, so here, yeah, we have the new indexes, and then we'll need to convert them into GL buffers. That's clever. Mm-hmm.
So this is not a... This is a buffer array. I'm sorry. This is...
Yep.
Okay.
Mm-hmm. Indices.buffer.
Okay.
Yep.
Great. Okay. Should we just finish this out and then see if we can? I don't think it's going to compile necessarily, or it's not going to draw.
It might compile.
Certainly. It'll compile.
Yeah,
let's get it to compile.
Let's see what it renders. Yeah, I was going to say that actually the most interesting problem here is that we already have a model named Tank. So actually, like it might be like comment out the triangle renderer and comment in the line renderer or line processor.
Yes.
So we'll lose like the internal geometry, but that's okay too. Well, yeah, let's see what we get. It's this close. Might as well.
Okay. Try mesh to line mesh. Well, we don't have a shader that... Well, I guess the shader doesn't matter. The shader doesn't decide whether it's lines or not.
The shader doesn't? You just blew my mind.
The shader doesn't care, right?
The shader doesn't care, and we already passed the primitive to the GL renderer, so it's fine.
Yeah.
Okay.
Okay. So, we actually need to... Let's build it up then. Okay, so what is the function that we had again? The other processor function, get GL buffer.
Yeah, and that is, I think, super extractable. I copied this out of the original function you wrote.
So we kind of need this, right?
Yep.
Actually, let's just take this whole thing.
That's it. Yeah.
Yeah. And then the indices. Are this.
Yep.
And then this is mesh primitive dot lines.
Yep. And model is now M. And that function doesn't exist. Yeah.
And we'll worry about what the home of that is in a second.
Yeah, I'm going to say nothing. So I think that's the wrong type now, which is annoying, because it's looking for. Oh no, did we wrap it in a UN16 array, or is it returning number array?
It is returning a number array, but
we should hand it something that is memory defined.
So UN16 array.
Yeah.
Buffer array.
Oh, because it's looking for
a buffer object.
Yeah, it's looking
That's fine.
Yeah.
What does a buffer object look like again?
It would be mesh. You could actually splat in m.mesh. Oh no. So we'll need a new object, and it's the buffer, which is that. The GL enum, which is whatever the float enum is. GL type. Yep. You actually. GL.float or GL.int? I guess that's not float for this, yeah.
Short, I believe. I think unsigned short is what it is.
Okay. And then there's a number of elements.
component count and components per attribute.
And that's great, because that's the other thing that we're going to change for lines.
Total number of component values of type GL type. So we need to actually have this in a line indices, right? Component count is the total number of component values. It's just line indices dot length, right?
Yep, correct.
Number of component values per attribute.
2. Sick.
That is it.
The function, yeah. All right. So does everything still build?
We have a couple compiler errors. Data mesh. Okay, that's just does it still build? Will it blend? I mean, it's running.
Yeah.
I mean, nothing should have changed right now, right? I don't.
Nope. Cool.
Okay.
So if you go back to Renderer 3D where we have
low GLTF.
Yeah, exactly.
And then the processor.
So you could just swap it out. Yeah.
I just need to import this, right? Does it get? Did we call it something different?
We might have renamed it.
Get GL line mesh.
What did I write? I wrote get. Beautiful.
Okay, it's not drawing anything anymore.
Doing good. So that needs the GL context passed in. And now I expect it to start drawing again.
Yeah. Okay. So it's just throwing an exception.
Yeah.
And then
so if you take,
what if we just replace the mesh with this one? Is that possible?
Yeah, totally. So it's line 617 is what's so render root nodes is our like set of named methods now. So you can comment that out, put it below there. Yeah. Or yeah, if you overwrite it, it'll just overwrite it.
Yeah.
Either works. Hell.
Nothing. No, this is all debug draw right now.
Too bad.
Yeah. Do you want to time box a debug? Do you want to do 5-10 more minutes debug this? Or?
Yes. My strange lack of errors. My question is, how many indices are in the buffer that we're returning?
Yeah.
Is it any?
Yeah.
And does the renderer respect line mode versus triangle mode based on the mesh, which I don't remember if we said or not.
And we only have one thing going in there right now, right? It's not too bad.
Turrets, but like, yeah, whatever. That's good, because I almost put everything into GLTF today to like get rid of the rest of the renderer that is OBJ and we don't need anymore. But not yet.
My VS Code is frozen.
Well, that's not good.
Everything was going so well.
Yeah.
All right, we're going to try one more time.
You found the one thing the M1 can't do, debug code.
Yeah. No, close it, please. That would be interesting if it doesn't work, and unfortunate, I think.
That would be really a bummer, yeah.
Debug game client. Okay. Oh, dang. That's totally working.
Delightful. Okay. Cool.
Okay. Now, where are my controls? Where are they? There are 5 different windows on top of it.
Oh.
If we step over, the line indices look like... I mean, they look like a thing. I don't know what it is, but it's a thing.
That does look
That looks
really...
pretty promising, right? It's a bunch of integers.
It's a bunch of, and it's a bunch of gaps, too, which I love.
Yeah.
Huh. Okay.
So let's Let's try that again, and this time, let us.
Shift reload? Did we kill it?
I think the server. Oh yeah, one of those garbage things. Yeah. Okay. This is a fun like moving all my zoom windows around kind of evening, which nobody can see. Nobody can see how deftly I'm accomplishing this.
Which I'm actually grateful that Zoom hides it all.
Yeah, it's great. Okay.
Huh?
Do we need to walk through this? I feel like
I feel like what got spit out there really should have rendered. Like
it should have rendered something. Right?
Yeah, I'm surprised it didn't. So
what if we turned off the terrain? How do we do that?
if we turned off the terrain? Oh, what color is it? That's a great question. Well, wait, it should have been visible somehow.
It should have been. It's cyan. It's whatever we were passing.
Yeah.
For. Oh, do we actually have a way of doing lines in the render?
That was my second question. Do we respect lines, or is it trying like bust
we don't
triangles?
respect lines?
Okay,
yeah.
great.
Is this render v2?
Mm-hmm.
Redner.
Huh?
Render body. Render node.
Huh?
Render mesh. This is the money shot right here, and we only
Triangles. Yeah. Okay, cool. So that's
well.
Oh yeah, there. Oh well, there's the problem.
You think?
Yeah, I thought I was thinking it might have like spit out triangles for lines, but the fact that it was totally eliding everything, that's great.
Reload. Let's get past this.
Right.
Oh, dude, that is
close.
That is very close.
Can you zoom? Can you like push the camera in, like in the camera?
We could use Render Toy.
Oh, is that doing V2? Yeah, open up Render Toy.
Yeah.
Hit it.
Yeah.
Oh man, we should have been. This is great. We can debug it in Render Toy next time. That'll be really helpful. I'm sorry. Is that it?
That is.
That's fucking right.
You can see a pixel hanging out there, but
let's not talk about that pixel. That looks great. Look at that.
Amazing.
So I think something is still treating.
So we're missing some things, but holy crap!
No, that's a wireframe renderer.
That's a wireframe renderer right there.
That's awesome. So I think something in our renderer is still sees triangles, because it looked like it was drawing like sort of munched up triangles there.
Where? Where on the tank?
Back on the game side. I think the game renderer is still doing something unexpected.
Well, we might be seeing. The thing is, we're not filling the Z buffer right now with the triangle mesh.
Mm-hmm.
So because we're not doing that, we're seeing the geometry behind stuff, which is not what. This is not actually the effect that we want. What we want is just the outlines with opaque faces. Right?
Well, go back to the game real quick and push the camera in. I feel like our renderer is doing something different than what you're describing. And maybe I'm just missing it through the zoom. I think maybe it's just a lot of lines.
It's just a lot of lines.
Okay.
Yeah.
Cool. Oh yeah, walk over to a turret. Let's see what a turret's doing.
The turret has a lot of triangles in there.
I noticed that, yeah. Oh, do you want to put the turret in Render Toy? We could do that.
Oh yeah, we totally can.
I like that you hide at the trees when you go away too. I do that.
I don't want to die.
No, of course not.
What is it called again? Turret?
Yeah, wherever there's tank, make turret. Yeah. All right, Render Toy, what's up? Oh yeah, this sucker's just fucked. Okay, cool. It didn't take out any triangles.
It didn't.
Like not a one? Not a one.
No. See this quad on the top? That doesn't have a diagonal.
Oh yeah, those. Okay, interesting.
So this is and also this quad on the side here.
great.
Well, hey, you know what? This is a massive win.
Oh yeah, it's so
and also
cool.
the quads over here. Also, this is a massive win. I did not expect for us to see anything this stream.
Yeah, you realize that you just wrote that code blind and ran it once and it worked?
TypeScript, baby. I'm serious. It's like
It
you
helps.
have static typing. It just like gets rid of like 99% of the issues.
No, that's super rad. So this is great. We can totally pick up from here.
Let's go back to the tank. The tank
is very impressive.
is triumphal. The turret is shameful. But this is really dope.
I did a really good job.
I don't know what degenerate piece of geometry. Do you see this tiny pixel here? It's not just dust on my screen. Yeah. That's a degenerate piece of geometry that is like in the mesh somewhere.
Did the tank have an antenna?
It did have an antenna.
I think that's the antenna.
Well, where's the... You're right, that is the antenna.
Maybe it's normal with straight up and we
out.
just got rid of it. No, I don't know.
Yeah, I don't know. I kind of want to do GL line width equals 2 and see what happens.
Do it, because I don't believe it's gonna... It can't work. Unsupported.
2.0, baby.
The entire browser's gonna explode.
Yeah, it didn't do
It
anything.
didn't do anything. That's too bad.
That's okay. I mean, they're implementing the spec here, right? I feel like we're missing some geometry too, right? Like you see how the turret is just kind of like floating off.
Oh yeah, look at that
gap there.
Huh. Interesting.
So we do have an issue where stuff is missing, like the antenna is missing somehow.
It's so funny to me that this took out too much of the model, and the other one took out like not enough. So.
Yeah, you can totally see that we're gappy, right? Mm-hmm. We're fairly gappy.
I'm kind of okay with gappy. It looks cool.
Yeah.
But yeah, we should fix this, and we will.
I'm very curious to know what, you can see where like there's whole pieces of the tank that are missing here. The whole bottom of it is gone.
Mm-hmm.
Yeah.
Interesting. Dude, whatever. This is sick.
Yeah. Okay.
Nice work just whipping that one out.
Yeah. All right.
The line
we should run away as quickly as we can.
Yeah.
This is like when you hit the 3-point shot from half court at the end of the game, and you run off court so they can't review it.
Yeah, it's time to walk out the stadium, call it a day.
Exactly.
We started with sports, we ended with sports. Sick, dude. That looks awesome.
Yep.
All right. Goodbye, Twitch. Someone's still out there. Thanks for hanging out.
Yep. Take it easy, everybody.